Welcome to Coding Adventures, everyone. In this episode, we're gonna discuss about All right, I'm back here. So Caesar Cipher, basically, it's an encryption algorithm, one of the very first encryption algorithms ever used, or at least it's a legend. But it's also very popular nowadays by the computer science, by encoding interviews. And the way this algorithm works is if you have a text and if you have also a key like a number, so you need to have a text and a key like a number, let's say key is 1, you encrypt this text and it will result something such as, I'm gonna write it, I F M M P, right? So you basically start with this text here and it results this one encrypted form using the key. So what we want to do is basically create a function that receives a text and outputs out the encrypted form, and we need also to write the other function, or perhaps use the same one, that will decrypt it back. So if we input this message here and we know the key, it will result back the original message. All right? So let's first understand what Caesar Cipher is, and it's a very simple encryption algorithm. Don't trust your most private data to it. It's not that secure. The way it's working, this key is basically telling us how we shift the letter. So if we're looking here at the alphabet, we choose the key 1, we are shifting to the right one. So H become I, then E become F, L become M, and and O become P, right? So that's why we ended up with this this text. Where the most difficult part is here. For instance, if we have a Z in the original message, let's put a Z. Hello Z. I don't know what it means, but if we have a Z, Z becomes basically, let's say, comes back to the start and becomes A. So here will become A. All right. So as you can see, it has this wraparound effect, right? So we'll see how to solve this one. But right now, let's switch here in the code and let's try to write it, you know, just the baby steps like we always do, not write it from the beginning in the most complete form here, but try to write it baby steps. So we're gonna write a function here. So let's name this one Caesar Cipher. All right, and let's write a function encrypt that will take a message as an input and also will take a key. Again, a key is basically a number from 1 to 1000, doesn't matter. But we're gonna make a convention here, encrypt. All right, we'll put the comments afterwards. We'll just assume the message has just letters from the English alphabet, and even simpler, we're gonna just choose just the uppercase letters. All right, so let's do that kind of assumption here. And the way to encrypt it is very simple. This algorithm that we just draw on the paper, we're gonna take letters from the message, we're gonna convert them to codes. Once we know the code is a number, we can shift them. Basically, we can add 1 to them. For instance, if the key is 1, if the original code was 65, for instance, we take letter A, we want to convert it somehow to number 65, obtain the 65 number, which we know that is the code of that letter. Then the next operation is the key, so it's 65 plus 1. It results 66, and then convert back 66 to text, and it is B. So in this way, see, we shift to the right with 1, right? So it's pretty simple. Let's iterate through all the letters first. So let CHR from character of message. So basically we iterate through all the characters of the message, and we obtain the code here, which is chr.codePoint at 0. All right. And here, let's use the function somehow. Let's say let encrypted. Okay, let's take a message first of all. Let's say, and we use uppercase letters. Hello world. Just like that. And let's say that txt and enc will encrypt this txt with a key of 1, right? And next we're gonna print, yeah, we can print also txt originally, and let's print also txt enc, like that, right? All right, so we need to do this kind of exercise. So we're invoking the function encrypt. Now, just for another test here, let's print the code here inside. And we're gonna invoke the function. We should see the codes. Yep. Yep, these are the codes of the letters. Of course, we saw the first text, the codes of the letter, and at the end it says undefined because this function doesn't return anything. So when this guy is trying to print, it's undefined. It's a special JavaScript feature. So, but of course, we don't have to print the codes inside here. But what we want to do, first of all, we want to add 1 to this code and obtain that letter. But also we want to basically say only if they're uppercase letters. We don't want to mess up with other letters, right? So the code, how can we say if they're uppercase letter? Easy, really easy here. We can compare the code. So basically we can say if code is greater or equal than 65, right? And 65 meaning uppercase A, and then we know that the rest of the letters are consecutives, basically encoded, and it's less or equal than, you know what, or letter Z, which is 65 plus 26 letters the English alphabet minus 1, because we just shift by 1. But instead of doing this calculation here, let's take in some constants. Code A is basically, it's A. Let's do this trick. Let's let the computer figure out that A is 65. We just say we need the code of A, and then we need the code of Z, which is Z. Okay, we know the code of A. So as long, now we are coming back into a looping inside the message here. If our code is greater or equal than code A, and our code is less or equal than code Z, so basically our, you know, we are in that range with the letters, we need to apply this shifting here, right? And the way we can do, of course, we can say code is code plus key, one way of doing it here, right? So we basically obtain a new code here, or we shift the code. And then what we can do, we can also have in a variable here, encrypted message starts empty. We start adding to this encrypted message, basically we convert the code back to a character and we add it to that encrypted message. That's what I wanted to say, right? So we are basically, oh, and we are doing, let's do this shift only if they are in this particular range. Let's not do it if they are in other ranges, but we are always adding it in to the encrypted message, because we want to add also the spaces and this punctuation signs, but this one we don't shift, just the main letters. So we're gonna say string from code point, and then we use this code here, right? And here return encrypted message. Let's see what we get. This is what we want to achieve. Although I'll be frank with you, it's not as easy, and we'll see in a second. But let's see what we achieve here. Let me save it first. In case I have an error, I don't want to get a crash. Oh, enc message. That's something else. Enc message. What? I put it correct. Oh, we're adding to this guy here, right? So looking at that alphabet, let me bring the alphabet here. H becomes I. You know, looks kind of correct. So let me go back to my code, and looks correct, right? It's correct here. let me see again. It's a shifted by 1. Yes, looks almost correct. Let's try to now shift it back. What if we put a key of -1 here? Will we be able to shift it back? Let's see. So the function looks complete at this point, but let's decode it back. Perhaps txt2, it's obtained by encrypting or calling this is actually encrypt decrypt. It does both functions, right? So let's call it encrypt decrypt. We'll call encrypt decrypt on the encrypted text this time. And the encrypted text we are shifting back -1. So because we want to go into the other direction. And here we're gonna print txt2. Let's see if it's working correctly. All right, so it seems to work correctly. Basically, we do this text, we shift it once, works correctly, we shift it back, works correctly. So encrypt decrypt seems to work fine. And you know, we'd be tempted that we're done with our code, but we still are not there yet. Let me show you why. Let me pick an edge case. Instead of hello world, first of all, let me pick ABCZ, something like that. We should see basically A becoming B, this one, but the Z should become A, right? As we saw on the paper. Let's see. Z is not becoming A. So the first 3 characters are okay, but the last one is not wrapping around, to say like that, right? We don't see this wraparound effect. And then we lost it here. We lost the message. All right, so why is not wrapping around? What we need to do here when we are adding it, if we are looking at the ASCII characters again, and if we are looking here in this table at basically Z, or let me go back, perhaps I have it also. Let me bring it back in a smaller window, like that. If we are looking at the character uppercase Z, see, we shifted by 1. So the next character after it was this square bracket. So the code performed correctly here, but we don't need to go from Z to the next one. We actually need to wrap around. So how can we achieve this wraparound effect? Let me show you. It's pretty easy, and you know it probably from the elementary school, in a sense. So let's remember the clock, right? Let's remember the clock. And let's say is 9 o'clock right now. 9 o'clock, right? What will be the hour after 12 hours? Well, obviously the clock will go this way and will come this way, so will be also. So we can say that 9 o'clock plus 12, in a sense, it will result 9 o'clock again, right? But what about after 15 hours? Well, after 15 hours, it goes back to 9, and there are 3 more hours here, right? But what about after 100 hours? Who knows? How can we figure out this really quickly? Well, this clock, it's what we call, it does wrapping around. First of all, we notice this effect of wrapping around because number 9 becomes again number 9 every 12 hours. So it wraps around every 12 hours. Or we can do the same with the minutes, right? If it's basically 15 minutes now, the hand of the clock it's pointing this way, where we're gonna point the hand after, let's say after 15 minutes? Obviously we're gonna point at 30 here, but what about after 1015? I'm putting a plus here, but obviously it's not a plus. After 2375 minutes, this hand will just go round and round and round and round, where it will stop. And this one is actually has to wrap 60 minutes, so it's similar to the hours. This one has to wrap for 12 hours, this one has to wrap for 16 minutes. So where the hand will gonna end up? And there is a very easy way to find that one in JavaScript, or at least on computers. It is called the modulo operator. So let me show it to you on Google, basically. So first of all, let me pick here 9. Let's say 9 plus 12, and we'll obtain 21. But let me put this one like that. Modulo 12. Remember that wraparound effect? And we said if the clock shows 9 hour 9 after 12 hours, where will be after 12 hours, right? We'll be at 9 o'clock again, obviously. So the way we do that, we say 9 plus 12, and we say modulo how many hours are on the clock, right? So what will be the hour after this huge number of hours, after 121,234 hours? Well, it's 9 plus this number, also modulo 12, and the hand will show hour 7. All right, and the same for minutes. So if the minutes are 6:15, after 15 minutes, of course we are working modulo 60 here, will be 30, right? So because it's 15 minutes, 30. But what after, you know, after 16 minutes should come back at 15, right? It's 1 hour past, it's 15. But what about a huge number? It just happened to be again 15. Let's pick a different number. It's 55. Right? So this is a very interesting operation, modulo, and we also discussed roughly or a little bit about it in the previous lesson. It looked like that reminder operator from JavaScript, so we're gonna try to use that one. The only difference is that here we are trying to wrap around. I'm gonna switch back here. We are gonna try to wrap around not against basically 12 hours or 60 hours, but again around 60. So around 26 letters, sorry, 26, right? There are 26 letters from A to Z. So what we're gonna do, we're gonna take the code, we'll shift it 1, but take that number modulo 26, right? So that's what we're gonna try to do here in the code. And with that one, we should obtain a good answer. But not before doing something else. The code here, so for instance, for letter A, the code is 65, right? And for letter B, the code is 66. Let's bring these codes in the range 0 to 25. So instead of being in the range, let's look here at the ASCII chart. Instead of being in the range 65 to 90 here, let's subtract 65 from them. So we're gonna bring them in the range 0 to 26, like A 0, B 0, C 0, and because we need the wraparound, only then it works properly. So before we actually add the key, let's subtract from the code 65, or we can subtract the code A, which should be 65. We do this operation, we add them, but we say that we're gonna add them modulo 26. We should get that wraparound operation, but code is still in the range 0 to 26. So let's bring it back in the normal range of ASCII or Unicode characters. We're gonna add back the code A. So we are shifting back. So the number should come back into the regular range. And now we are converting it from that one into code. Let's see this one. Let me save it. Run it. Well, almost a little bit better. Let's see. We had the original text A, B, C, Z. It was encoded as B, C, D, which is correct. And Z jumped to A, which is also correct. But we have a problem with decoding. We have a problem, in other words, when we are converting A to Z, when we go in the other direction, because we have to wrap around in the other direction, right? And you know why we have this problem here? The answer may surprise you, but let me read first the answer to the riddle. The answer is, I'll let you know as soon as I finished eating. Thank you, Success Path. All right, so let's see why it's working to encode it now, but doesn't work to decode it. Really interesting. I'm gonna show you something that will surprise you. Let me open another code page here of code and show you something. I can close this one. Let's print perhaps 7 modulo 3. What will be the answer to this one? It's 1. So this operator, we use it until now not as a modulo, but as the reminder of division of 7 by 3. So we know that basically when we divide 7 by 3, we can also say that it's 2 reminder 1, right? So that operation is returning this, basically this 1 here, which is correct. And let's go on Google and do this kind of calculation on Google. 7 modulo 3 or a reminder 3 is 1, same as here. Okay, fine. What about if we have, let's say, first of all, 8 reminder 3. Let's take one more example. What will be the result is 2, of course. 2 times 3 and plus 2 is 8. If we go here, 8 modulo or reminder 3 is 2. So same result. Google confirms the JavaScript finding. But let me put here a -8. Let's run it. It's -2. Remember, -2. Let's put here a -8. Let's run it. It's 1. All right. All right. How can be this different? So Google says -8 modulo 3 is 1. JavaScript says -8 modulo, or this percentage sign, 3 is -2. We have two different results. And this is actually the key to the problem. What Google is doing here when we put this sign is actually using true modulo operation. This is modulo, even says here -8 modulo 3. What Java is doing when we use this operator inside the code, it's basically doing the reminder, which for positive numbers, this modulo operation is the same as the reminder. That's why our code works when we shift it to the right, but doesn't work when we shift it to the left. We need actually the modulo operator, not reminder. Again, JavaScript, the percentage sign, although people usually at a glance they say this is the modulo operator, is not modulo, is the reminder. Keep in mind this differentiator, because other languages such as Python, since we discussed Python today, in Python this operator is actually modulo. So if you do this calculation in Python, you'll get, or with -8 basically, you'll get the same response as with Google. Well, in JavaScript this is the reminder. And if you have a program in Python and if you want to convert it to a program in JavaScript, be aware about this one, because you have to do some adjustments, otherwise it's not a direct conversion. However, let's observe again this, this kind of behavior. So basically, see, in JavaScript is -2, in Google is 1. If we are adding to -2 the actual number, -2 plus 3, we are ending up with this one. And this is actually the key to our problem, how to actually implement a true modulo. I would also, point you to read this article eventually if you have time. There's here, let me see if I can locate it really quickly. Oops, perhaps I should zoom out a little bit. Yep, this one. It's about the same thing that we are doing today, and it's showing these calculations. And also in here, you're gonna see 3 ways of actually doing modulo true modulo within JavaScript. These are from various authors on the internet, and you can see there are different ways of actually achieving it. One is by solving the actual equation, and like if you have the multiplication plus reminder and you obtain basically the that kind of reminder. The other one is what we discussed today. You can add that that number to the if the result is less than 0, you can add actually by the number that you're trying to use in the operation. And let's implement this function ourselves, and we should basically solve the problem, right? So again, we are back to our program here. If we run it, we can encode correctly, but we cannot decode correctly. So instead of this operator, we need a true modulo. So the way we're gonna do that, we're gonna create a function mod from modulo. So we want to calculate modulo of number basically n. When we divide n by p, we want to obtain the modulo of that, which again for positive numbers is the remainder. For negative numbers, it's we have to do something different. So first of all, let's obtain the remainder in JavaScript, which is an percentage sign p. We obtain the remainder, and then we can say like this: if if remainder is less than 0, we notice that JavaScript is producing reminders less than 0 when n is negative. If remainder is less than 0, we're just gonna add to the reminder. We're gonna just add to the remainder the p number. So if it's modulo 3, we add 3, and so on. And then that's it. This happens only if that is less than 0. Otherwise, this branch is not executed at all, and we're actually returning the actual reminder. So we are returning R. Let's see if we wrote it correctly. If not, we're gonna switch to that article. Again, these are algorithms written by various people to calculate true modulo in JavaScript. Take no credit for that. But let's now see how can we use this one inside here. So instead of this line, what we're gonna say code equal, we're gonna do modulo. So basically use this function between this guy here and the second argument. We don't need this parenthesis, and the second argument should be 26, just like that. So we had to write our own modulo function in order to do that calculation. Let's run it, and we can see here perfectly easy. I think we wrote the functions correctly. Let's put here a real good message. Thank you for watching. Happy coding. See you next time. This is the last exercise in the lesson. And yep, thank you for watching. Happy coding. See you next time. This project was extracted from my JavaScript course for absolute beginners here on YouTube. The course has tons of projects such as this one. Please watch all the episodes by using the playlist link in the description. If you like the channel, please subscribe and activate notifications. See you next time!